y1 is equals to y0 plus, this is the length of the interval, we show it by h by 2 f of x0 y0 plus f of x1 and y11. If you remember, we had written down the equation for y1 in advance. If you remember, we have just written down, and this was equals to y11 is equals to y0 plus h times f of x0 and y0. Now we are putting this value over here, so the result is from y0 plus h times f of x0 and y0. Okay. If you go through all the terms on the right side, you will see this is slightly different, and all the terms other than this one contains x0 or y0. So we can replace this x1 to create a symmetry in the result. Y0 plus h by 2 and f of x0 y0 plus this x1 can be written as x0 plus h and y0 plus h f of x0 y0. Okay, so now this result takes the form like that, and further we got this result only for the interval from 0 to 1. If we proceed on the same lines, you can see once again, if you look at it on the right side very carefully, we are using everywhere either x0 or y0, and x0 and y0 are basically the initial conditions. So in order to obtain the next better approximation in the form of y1, we are using x0 and y0. Similarly, if we want to find the next approximation in the form of y2, so we'll be using the previous information which we have just obtained. So the change on the right side will be y1 plus h by 2 f of x0 y0 x1 y1 plus f of x1 plus h y1 plus h times f of xm yn y1 and the result x. Similarly, if we keep on doing, generally we can write it in the form of ym plus 1 is equals to ym plus h by 2 f of xm ym plus f of xm plus h ym plus h f of xm ym. So this becomes your ultimate second formula, which is named as the improved Euler's method. Okay, so after deriving these two formulas, we have to use them in order to solve the problem. So let's start solving the problems. Okay, here we first summarize the two formulas. The first formula for the Euler's case, we obtain ym plus 1 is equals to ym plus h times f of xm and ym. This is the first formula we obtained for the case of the Euler's method. This is your Euler's method. And second formula we obtained, this is still on the board, you can see. So this takes the form ym plus 1 is equals to ym plus h by 2 f of xm ym plus f of xm plus h ym plus h f of xm and yn. So this is your second formula. Here now we are given a question to approximate the solution the question is, you have to solve the differential equation dy over dx is equals to 1 minus y along with the initial conditions of y0